So we're back with more basic rules of differentiation. In the previous video we covered the constant rule and the power rule. In this one we're going to go through the constant multiple rule. So that's our third one. And we'll cover the sum and difference rule. These are actually pretty simple. Most of the time you actually forget the names on these. Not a big deal for most part. You do need to know power rule for sure. So the constant multiple rule is basically if I'm taking the derivative of a function where I have the constant out front, okay, of the function, basically he just comes along for the ride. So he doesn't change, but remember we are going to take the derivative of the function, so f prime of x. I know mathematically that looks really weird and you're not used to the notation yet. But let's look at a couple examples, and I think you're going to find this very, very easy. So here's your examples. So let's say we have f of x is 5x squared. Okay. What that means is if I'm going to do the power rule here, because I see that I have an exponent, so the first thought is power rule. Normally we would just bring that 2 out front. Well, obviously it's not 52. So it's just going to be 5. That guy just comes down. Notice that c did not change. The constant just comes along for the ride. What changes is this functional piece. So we're going to call this c, and this is my f of x. I hate to do that. Okay, fine. I'm going to call them g's at this point. So f of x. So here I'm going to do my power rule. So 5 times 2 to the x. 2 minus 1 is 1. Obviously we normally don't write it like that. So with the first power there, the way we write it is just 10x. Okay, really a quick one just like that one again, just if you're not comfortable with it. So let's call h of x, I don't know, 20x to the 5th. So h prime of x is going to be 5 times 20. So you can just multiply. You don't have to do this step. 5 times 20 is 100. Leave that x there, subtract 1 from 5, you get 4. And there is your constant multiple rule. Okay, this will work with, I'm just going to kind of keep going with this for a second. I know the rule makes sense, but I just want to show you more power rule questions. So let's say I have, I don't know, j of x, I'm just making it up now. 19 over x squared. The big thought is if you see these functions, you should want to rewrite them in a nice format like the power rule. So we're going to make this, remember 19 stays out front. This guy's going to come up to my numerator, and when it does, it turns into a negative exponent. So to find j prime of x, I'm going to do negative 2 times 19, that's negative 38x. To the negative third. Remember, subtract 1. Do not add. That does not turn into a negative 1. Please be careful there. Let's just do one more. Let's go back to our good old friend f of x. Let's make it hideous looking. Really hideous looking. So we have the radical sign, which you don't like to see. It's in a denominator, which makes life worse. We're going to rewrite that function. So we're going to rewrite that. 25 is going to stay as a coefficient. He's just a constant. This is going to come up into my numerator. Maybe we'll do it this way. We'll leave it down there. We're going to change it to the 1/3 power, which means f of x is now 25x to the negative 1/3. And from there, I can take the derivative using the power rule in combination with the constant multiple rule. So what I'm going to get is f prime of x equals negative 1/3 times 25. Well, they don't play very nice. We're just going to leave it as negative 25 thirds x to the, remember, subtracting, negative 4 thirds. I don't want to see 1 and 1/3 right there. We like improper fractions. Leave it improper, please. Sum and difference. That's the fourth one. And it's really simple. So basically if you're taking the derivative of two terms, So we'll call it f of x. Adding or subtracting g of x. You can just do them separate. So you're going to get f prime of x plus or minus g prime of x. So what's that look like? Because I know, you got to get used to seeing this. You got to know how to read this one day. But for now, I know it's very, very strange looking. So if I have, say, f of x is x cubed minus 8x plus 7. There's my function. I want to take its derivative. It's just 3 little pieces, okay? So f prime of x. So we're just looking at, like, this would be like f of x, this would be like g of x, and this would be like h of x, okay? Just thinking about them as 3 little pieces. And we're just going to focus one at a time. So here I'm going to do a power rule. So 3x squared. Here I have negative 8x. Remember, that's a 1. That's a 1. So 1 times negative 8 is negative 8. No exponent, or sorry, no x at this point, because it's really x to the 0, so we just leave it. And then the plus 7. What happens to the plus 7? It's a constant, so it's just 0. So I guess I could write it like this. We never would. But hopefully you can see now, power rule working with a constant multiple rule, and here's a constant. So the rules all flow together. So f prime of x is 3x squared minus 8. We'll end this video right here, pick up a couple more examples in the next video. So hopefully this helps.